Hello students, today we'll be solving question number 1 from the part B of the MSc CMI data science question paper for the year 2018. So these are basically subjective type of questions, or we can say also descriptive side of questions. So these are the questions that we'll be trying to solve one after another in the various series of videos that we'll be taking up in this regard. So today we'll be starting off with question number 1. So in question number 1 it has been said that let n be equal to the set 1, 2, 3, basically the set of natural integers, okay, and f be a function which goes from n cross n to n and is defined by f of mn is equal to twice m minus 1 into 2 to the power n. Now is f injective? If is as surjective, give regions. So these are the things that we need to follow over here. So now what happens if suppose f is injective? If f is injective, this basically means that if we have some if we have f of m1 comma n1, okay, and f of m1 comma n1 will be basically equal to f of m2 comma n2 if f is injective. So in that case we know that this will be equal to twice m1 minus 1 into 2 to the power n1. This will be equal to twice m2 minus 1 into 2 to the power, it will be n2. Okay, so now as you can see over here, this is basically, this is the even part and this is the odd part. Okay, so now, so that basically means that the odd part must be equal to the odd part and the even part must be equal to the even part. So that implies that twice of n1, if we consider the even part, twice of n1 will be equal to 2 to the power n1 will be equal to 2 to the power n2, and this implies that n1 will be equal to n2. And for the odd part we'll have twice m1 minus 1 will be equal to twice of m2 minus 1, and this will give us that m1 will be equal to m2. Okay, so this is the structure over here. So that implies that if n1 is equal to n2 and m1 is equal to n2, in that case f is injective. Okay, now we'll go on to the case where f is surjective. If f is surjective, now for f of surjective, what we'll try to do is that suppose we have any, let us take a natural number, suppose small n. Okay, this is a natural number. Now this small n, if we do the prime factors, then it will have some 2 to the power a into suppose 3 to the power b into c to the 5 to the power c and so on. Okay, prime factors. Now this a can be equal to 0, may not be equal to 0, whatever. Okay, but this there may be a possibility that there are no 2's, there may be a possibility there are no multiples of 3 or 5, whatever. But you can see that there is an even portion which is denoted by the given by the 2 to the power a, and there will be an odd portion which will be given by 3 to the power b into 5 to the power c and so on and so forth. So as you can see, this part is basically the odd part and this part is basically the even part. So as you can see, this odd part we can write it down. This odd part may be equal to suppose twice m minus 1 for some m. This is an odd part. So we can definitely write any function in the of f of n. We can basically take any natural number and then we can break it down in the format of 2 to the power m minus 1 into 2 to the power a. So this form. So as you can see that for any natural number we can say that f is also surjective. So f is injective, f is surjective based on the different combinations of conditions that you want to apply over them, and thereby you get the result. So this is the process in which you solve question number 1. In case you have any doubt regarding the process that we followed over here, then you can comment in the comment section below and we'll try to get back to you. Thank you very much.